Hey guys, this is a quick tutorial on how to get percent mass to volume in milliliters. You guys need to be familiar with being able to convert between units of measurement, but not not parts per million or parts per billion for this. But if you're going to take like the MCAT or the PCAT or any of that stuff, I think that's the PCAT. Anyway, the pharmacy admissions or any of those, you need to learn the parts per million and parts per billion. But for our test purposes, we're not worried about it. So, a sample of water contains some amount of contaminant, and that is given to us in some percent mass. And I'm calling whatever's in there some random element, and I'm abbreviating that RE. So if you see this RE, it's random element because it can be anything. And I'll show you why. So, how much water contains however many milligrams of the random element? So, what we're wanting to solve for is how much water we're wanting to know how much the volume is. So, what we can do is we can convert milligrams using like the conversion for how many grams are per milligram. So, like in 1 milligram, it's 1 gram per, 1,000 milligrams. So, you guys can just solve that. Anyway. So if we said that this was 12% for some random reason, so just fill that in. 12% by mass. So all that means is that's 12 grams of the random element per 100 grams of water. If this is aqueous, because we were talking about water up here. So yeah, it's water. It's not aqueous because it's not an ion dissociating, but that's a whole other thing. Anyway, this is just a conversion factor. So it's like whatever this percent was is in grams of the random element over 100 grams. And this isn't a percent anymore. It's just whatever that percent was is the equivalent of this number of grams. That's why I said if it's 12%, it's 12 grams. If it's less than this, if it's like some minuscule 0.000009% by mass, you would put in that 0.00009 over 100. Okay, and then you can flip that over also to 100 grams of water over however many grams was equal to whatever you had in here of that random element. And that's another conversion factor. So, and then because we're working with water, we know its density is 1 gram per milliliter, which can also be flipped around to 1 milliliter per gram. That's not the same as density. That's like 1 over density. But anyway, you can use this. And you guys need to have the density of water on your note card if you don't have it memorized, because it will not be given to you. So, if I set this whole thing up, I'm going to have some number of milligrams of the random element times the conversion between grams and milligrams of the random element. And you see how I'm labeling that these masses belong to the random element? That's because when you guys start working with these multi-substance solutions that involve like densities and stuff and masses of different things, you guys have to label it or it gets really easy to get confused. So anyway, we have blank milligrams of random element times this conversion factor of grams over milligrams times the 100 grams of water over whatever this was grams of random element. And we got that from up here, which that came from the percent. So if you can follow that logic, you can know where this comes from. So, and then this is just the density of water upside down. So, and that'll give us some number of milliliters. So that ought to help.